us. It was when I was just a wee little child. Thank God I had the YouTube to teach me how much different the universe is compared to what I thought it was. Like, for example, you got UCLA astronomers making the first accurate measurement of oxygen in a distant galaxy. Okay, great. So we got an entire galaxy filled with oxygen or air. So like you could be walking around outer space, being like breathing in, like, hell yeah, I'm breathing in outer space, which is totally different than we were told you could do. You know what I'm saying? Like, what would it be like if you could breathe in outer space in our solar system? It'd be crazy. You know what I'm saying? We could walk to the moon or skateboard to the moon, I guess. And then over here, we got the ESO telling us you got stellar outbursts, which brings water snowline into view. That's right. So you got one solar system that's breathing oxygen and that you can breathe in, and you got another where it's snowing. You can literally go snow skiing in outer space, asterisk. So I'm just saying, they used to say like, oh my God, water's so rare. It's only on Earth. And then they're like, oh yeah, it's on Mercury, it's on Venus, it's on Mars, it's on Jupiter, it's on Ceres, it's on Pluto. You know what? I bet there's sound in space. Wait, they didn't used to say that. I just said that now. But I bet you can totally hear sound in space.
In space, no one can hear you scream.
Every day.
Stay cool.
T-minus 5, 4, 3, 2, 1.
Hit the button, baby.
Party dance time.
Got for me.
An update.
Good morning, folks.
Are you cool?
Hey, everybody. It's a heads up.
This is space. There's space all over the place.
Eyes to the skies.
Because I'm going to be dropping some hard Thor News science upon you. This is a Thor News presentation. Thor News presents... Alright, young stars are often surrounded by dense, rotating disks of gas and dust, known as protoplanetary disks, from which planets are born. You see, the heat from a typical young solar-type star means that the water within a protoplanetary disk is gaseous up to distances around 3 AU, astronomical units, from the star. That's less than 3 times the average distance between the Earth and the Sun, or around 450 kilometers, if you're calculating it out at home for fun. Further out, due to the extremely low pressure, the water molecules transition directly from a gaseous state to form a patina of ice and dust, grains, and other particles. The region in the protoplanetary disk where water transitions between the gas and solid phases is known as the water snow line. Wait, what, man? Like, now you're talking about it like there's just a whole lot of water around almost every star there is. Like, when stars are forming, oh yeah, there's just a natural giant pocket of water that either moves in or out on the protoplanetary disk. Seems to be a lot different than I remember it. I don't remember water being a part of solar system formation all the time. But the star V883 Orionis is unusual. A dramatic increase in its brightness has pushed the water snow line out to a distance of around 40 AU. Oh, roughly the size of the orbit of a planet Pluto in our solar system. The huge increase combined with the resolution of ALMA at along baselines has allowed a team to be led by Lucas Caesar to make the first ever resolved observations of a water snow line in a protoplanetary disk. That is exciting. The ALMA observations came as a surprise to us. Our observations were designed to look for disk fragmentation leading to planet formation. We saw none of that. Instead, we found what looks like a ring at 40 AU. This illustrates well the transformational power of ALMA, which delivers exciting results even if they're not the ones we were looking for. That's an interesting thing for a scientist to say. I wonder if that ever happens and then they put in the information they were looking for anyway. Nah. The bizarre idea of snow orbiting in space is fundamental to planet formation. What? Man, this story hurt my brain seed, and my sense of humor is now toast. Soggy, cold toast. Nobody likes soggy, cold toast. Not even English people. Man, I've become something nobody likes. Crap. The presence of water ice regulates the efficiency of the coagulation of dust grains. The first step in planet formation. Yeah, kids, you know how planets form? It starts with the coagulation of dust grains. And then step 2 is magic. In step 3, you have a fully formed solar system. Man, I'm in the mood to coagulate. I think. I don't really know what that means. I'll have to look it up eventually. Maybe it'll be my word of the day on my word of the day calendar. I'll keep my fingers crossed. Within the snow line, where water is vaporized, smaller, rocky planets like our own are believed to form. Outside the water snow line, the presence of water ice allows the rapid formation of cosmic snowballs, which eventually go on to form massive gaseous planets such as Jupiter. Oh my God, that is so ridiculous. Is this a joke? This has got to be a joke, right? Like, if they're real close to the sun, the water forms rocks. If they're real far away from the sun, the water forms Jupiter. Boom. Science. It's up your butt, Joe Boo. All right, let's see if UCLA had anything as ridiculous to say. You just make crap up. You just get that scientist badge and you go around saying, oh yeah, dark matter killed the dinosaurs. Oh yeah, dark matter formed the solar system. Oh yeah, we're stuck in 1888 technology because of religion. Well, I guess that's true because economics is a true religion. UCLA astronomers have made the first accurate measurement of these nuts. Wait, that's not what that says. UCLA astronomers have made the first accurate measurement of the abundance of oxygen in distant galaxies. That is just crazy. You got space air. Hey, everybody, I'm selling space air. It's like real air, but it's way more expensive. Oh, I got a cat attacking me. Oh, my God. This cat wants some attention. We all want a little attention. Did you know oxygen is the third most abundant chemical element in the universe? It's created inside stars. Oh, really? And released into interstellar gas when stars die. Well, they say you shit your pants when you're hung, so I guess that's the same thing for a star. You oxygenize, or as Sage likes to say, the oxidation event. What? The great oxidization event. It's like the Big Bang of air.
That was crazy.
There was no air, and then bam, there was air everywhere. Oh yeah, man, this science is fun. Just make shit up. Okay, we don't have oxygen in our solar system. Why?
Oh, we will. The great oxidization events have to happen on all the planets. Life's all over the place.
We're looking back in time at this galaxy as it appeared 12 billion years ago, said Alice Shapley. I would ask if she's shapely, but A, that might piss Sage off, and B, that would be sexist. Because, like, if there was a dude, like it was Frank Shapley, I wouldn't be saying, hey, is Frank Shapley shapely? You know what I'm saying? All right, that joke's stupid. I'm fired myself. Thor, you're fired from Thor News. Luna the cat, you now have my job. Cosmos 1908 contains approximately 1 billion stars. In contrast, the Milky Way contains approximately 100 billion stars. Yeah, they counted them all. I guess it was just like a jar of gumballs. And they looked at pictures and was like, yeah, it's about 1 billion. And the other one's about 100 billion. Shapley said that prior to Sanders' discovery, researchers didn't know if they could measure how much oxygen there was in these distant galaxies. Why would you need to measure how much oxygen was in a distant galaxy?
Maybe I move there.
To characterize the chemical contents of Cosmos 1908, Sanders analyzed a particular wavelength in the most far spectrum of this galaxy that is sensitive to the amount of oxygen. Oh my God, seriously? I got a camera that'll tell me how much oxygen there is. I went and took a photograph outside and said, see that whole frame? That's how much oxygen is in this frame. It's filled with it. Did I mention that I'm gonna carbon date your face with my carbon dating? All right, God bless everybody. Man, the universe is totally different than they taught us it was when I was just a wee little child. Thank God I had the YouTube to teach me how much different the universe is compared to what I thought it was. Like, for example, you got UCLA astronomers making the first accurate measurement of oxygen in a distant galaxy. Okay, great. So we got an entire galaxy filled with oxygen or air. So, like, you could be walking around outer space, being like breathing in. Like, hell yeah, I'm breathing in outer space, which is totally different than we were told you could do. You know what I'm saying? Like, what would it be like if you could breathe in outer space in our solar system? It'd be crazy. You know what I'm saying? We could walk to the moon or skateboard to the moon, I guess. And then over here, we got the ESO telling us you got stellar outbursts, which brings water snowline into view. That's right. So you got one solar system that's breathing oxygen, and that you can breathe in. And you got another where it's snowing. You can literally go snow skiing in outer space. So I'm just saying, they used to say like, oh my God, water's so rare. It's only on Earth. And they're like, oh yeah, it's on Mercury, it's on Venus, it's on Mars.